Hello everyone. So today let's take a look at Kubernetes automation. So recently I've been reworking my Kubernetes workflow. So what I'm trying to do is create a single versatile project from where I can deploy all of my Kubernetes clusters. So I need to be able to spin up clusters fast and reliably. I want it to be simple to use and customizable, and ideally it should be a single command deployment, or at least just a few commands to be able to deploy a full Kubernetes cluster. So today we're going to look at the first part of that. We're going to deploy a production-ready Kubernetes cluster in the cloud, complete with load balancing, ingress, and some default applications. But first, I want to take a look at some requirements and principles that I noted down as a guide or a blueprint that I can follow when creating this project. So the first requirement, obviously, is that we need to automate everything. The entire process of spinning up the cluster, bringing down the cluster, or provisioning some extra applications in the cluster has to be automatic. And definitely this means that we're going to be using infrastructure as code. So this is going to help us maintain consistency. We can be sure that every single cluster that we deploy with this project will be the same, have the same features. And then we're also going to be able to reuse the same project to create multiple clusters. And then idempotency is also important, because every time we run a Kubernetes deployment operation, we only affect the parts of the infrastructure that are changing or that we are adding onto the infrastructure. This helps us not disturb any existing resources that we might have already deployed with the project. And of course, since we are defining everything as code, we are going to be able to version control our project, so we can have a history of the evolution of the project and be able to roll back in case we need to. Then we need it to be customizable, meaning that you can change how many servers you want to run in your cluster, the type of the servers, how much CPU memory you want for your servers, if it's in the cloud, what region you want to deploy it, what operating system the servers are going to have, and a lot more things that we can be able to customize with the project. We want it to be cloud agnostic. It should be able to deploy to any cloud. We should also be able to deploy it in on-premise environments, or maybe in the home lab as well, and whether we're using VMware, Proxmox, or any other kind of virtualization technology. We also want it to be infrastructure as code tool agnostic. So in cases where Terraform is the best fit for the project, we can use Terraform, or maybe we can use Ansible or Pulumi, or any other kind of infrastructure as code tool. We should also be able to choose what kind of Kubernetes distribution that we want to deploy into our cluster. So as a start, we shall be leaning towards the more lightweight Kubernetes clusters like K3S or MicroK or Talos. And then you can add more Kubernetes distributions in the future. And then it's important for the project to have a good foundation with extensibility in mind. For example, if we want to add additional IAC tools or different cloud providers, or want to add support for additional Kubernetes distributions, it should be easy for us to extend the project and plug in additional functionality. So for a start, we're going to start with Terraform and a single cloud provider, and then you can build on from there. So we have our infrastructure as code component. Then you have our infrastructure providers in the infrastructure as a service component. Then you have our Kubernetes component, which will have the supported Kubernetes distributions. And then our apps component, where we can specify a suite of applications that we want to be pre-installed when we deploy a brand new cluster. Yeah, so basically we interact with the infrastructure as code component and use any kind of infrastructure as code tool that we have available to us. This could be Terraform, Pulumi, or Ansible. Then we could use that to provision infrastructure in the cloud. This could be in your home lab, for example, like on a Proxmox host, or in the cloud with a cloud provider like UpCloud. And then we can take our pick of the available Kubernetes distributions and then deploy some default apps, like maybe you want ingress in your cluster, or you want some certificate management. So today what we're going to do is we're going to use Terraform to deploy a K3S Kubernetes cluster in UpCloud. So UpCloud is a super simple cloud provider with a wide range of cloud services. They offer price competitive servers from as low as €3. They also offer load balancers, object storage, managed Kubernetes, virtual private clouds, and much more. And what I particularly like is their very mature Terraform plugin. It is very well documented and easy to get started, and it's going to come in very handy in our project today. And if you're concerned about your GDPR or data sovereignty needs, there's no need to worry, because they have servers located in multiple data centers across Europe. So they were kind enough to offer me a discount code which you can use to get started with with an extended 30-day trial period and $50 in free credits. You can use the discount code MORES50 to claim your free credits now, or check the link in the description and give it a try. So let us see how exactly this is going to be done in Terraform. We can take a look at our Terraform project structure. So we're going to represent all of the different components in our project as Terraform modules. So we have the infra module, which obviously helps us deploy our infrastructure in a cloud provider of choice. And we have the K3S install module. This is going to deploy a Kubernetes distribution onto the servers that have been provisioned by the infrastructure module. And then we have our apps install module, which is going to deploy some default applications onto the Kubernetes cluster once it has been successfully deployed. So the infra module is going to deploy the control plane VMs, the worker VMs, the private VPC, load balancer. Make sure that SSH is enabled on all of these servers and that the necessary SSH keys have been added onto these servers. So in order to send information from one module into the next module, we're going to be using outputs. For example, the infra module is going to be outputting this details about the infrastructure that it has just provisioned. For example, things like the control plane IP addresses, the worker IP addresses, the load balancer DS name. These are all details that are required by our next module in order to successfully install a Kubernetes cluster. So these outputs that have been outputted by the infrastructure module will be inputted into the next module, which is the K3S install module. The K3S install module is going to go ahead and install some prerequisites, and then once prerequisites have been installed on all the servers, it will go ahead and install the Kubernetes distribution via SSH or using API, like with the case of Talos OS. So as an input, the K3S install module will require the IP addresses of all the nodes in the cluster, the control plane IP addresses, as well as the worker IP addresses. The load balancer DNS name is also required, because if we want to access our Kubernetes cluster through the load balancer DNS name, it has to be added to the Kube API server certificate as a subject alternative name. And once again, once the K3S install module is done provisioning the Kubernetes cluster, it will provide some output about the installation process. And then most importantly, it should produce a kube configuration file, which is basically the credentials to access the cluster and deploy applications to the cluster. And then finally, we have the apps install module, which is going to be used to deploy the default applications like traffic, search manager, and whatever default applications you want pre-provisioned in your cluster. So now let us take a look at the actual Terraform code that is to help us manage and deploy Kubernetes clusters. So this is the root of our project directory. It's called the K3S auto directory. And then here, as the first infrastructure as code tool, we have Terraform. So we could later add on some other infrastructure as code tools like Ansible or Pulumi. And then inside the Terraform folder, we have all of our Terraform files that are going to help us to deploy and manage our Kubernetes clusters. So if I click on the modules folder, you'll see that we have three different modules. We have the infra module, which is going to be helping us to provision the servers that we need. Then you have a K3S install module. This is going to help deploy a K3S distribution onto our servers. So like we mentioned earlier, we could always have multiple Kubernetes distributions here, so we can add different Kubernetes distributions later on in the project. And then finally, we have our apps module, which is going to help us deploy some default applications to the cluster like traffic or search manager. So in the main.tf file in the root of the directory is basically where we're orchestrating the entire deployment process. So we have the module that helps us deploy infrastructure into UpCloud. And then after that, we have the K3S install module, which will help us deploy a K3S Kubernetes distribution onto the servers that we have provisioned. And then finally, we have our default apps module here. So you can see that the source of the infra UpCloud module is the infra UpCloud module's own Terraform directory. So in this case, it's located under modules, infra, providers, UpCloud, Terraform. So each module definitely needs some values or some variables passed into the module. So for example, when we are deploying our infrastructure, when we create servers, we're going to be adding some SSH keys, which will help us later on with access to the servers. Then we can set some other values like the name of the Kubernetes cluster, the zone these servers are going to be provisioned in. This is an UpCloud zone. This could be basically any kind of region supported by the UpCloud provider. Then we can also define the type of the server with the server plan and what operating system we want these servers to have. So then once this module is done provisioning the infrastructure infrastructure into UpCloud, then it's also going to produce some kind of outputs or details about the infrastructure that it has just provisioned. And that is what we are computing here in the local section. So we're getting some of the output from the infra UpCloud module and then saving that into variables that are going to be later on used by the subsequent modules. For example, we need the control plane IP addresses, we need the worker IP addresses, we also need the private IP addresses as well for both the control plane nodes and the worker nodes. And then we also need the load balancer DNS name, which we're going to be using as the DNS name for our Kube API. So now moving on to the next module, which is the K3S install module. So this is where we're going to be deploying actual Kubernetes distribution. So we make sure we set depends on to particular module because we want it to run after all the infrastructure has been provisioned. Yeah, so since now we're going to be interacting with the servers that we have created via SSH, we also need to provision some SSH credentials that are going to enable us to connect into these servers. Then of course we need to also know where the servers are, what are the control plane IP addresses, what are the worker IP addresses, and then in order to add the DNS name of the load balancer as a subject alternative name to the Kube API certificate, we also need to pass this variable into the K3S install module. And then once again, just like the previous infra module, we are also going to be collecting some outputs from the K3S install operation. So we need to know how the prerequisites installation went. We're going to collect some outputs from the K3S install module. So we're getting outputs about the prerequisite installation operation, the installation of the K3S server, the installation of the control plane, the installation of the worker node, as well as the kube config file. And then once our Kubernetes cluster has been successfully deployed, we can create a kube config file using the local sensitive file Terraform plugin. And then finally, we have our apps install module. So our apps install module is going to be able to connect to the control plane nodes via SSH and deploy some of the default applications like traffic and sat manager. And of course, it's also going to have to run once our Kubernetes cluster has been successfully deployed. And in this case, it also needs SSH credentials as well as the IP addresses of our control plane node. So this is the main .tf file that is in the root Terraform directory. So this file is the one that we're using to orchestrate the entire deployment of our Kubernetes cluster, and it's calling on the modules that we have defined in our modules folder. So first, we can take a look at our infra module. So if I go into the infra module directory, you can see that I have a providers directory. So like we mentioned earlier, we can simply add multiple providers into this section. So if we have like Proxmox or VMware or any other cloud provider, we can add it here. So here I have just the single cloud provider, which is UpCloud. And then inside of UpCloud, I have the Terraform folder, which is where I'm defining the infrastructure as code files that are going to help us deploy all of the infrastructure that we need for our Kubernetes cluster. In the versions file is where I'm defining the required providers. And of course, we are going to be using the UpCloud plugin, which is the Terraform plugin that helps us interface with our UpCloud account and be able to provision infrastructure into UpCloud. Like I mentioned earlier, UpCloud has a very mature Terraform plugin, and there's lots of documentation on how you can get started with Terraform. So you can take a look at the documentation, and there are multiple guides that can help you get started easily. So in order to use the UpCloud API, which is definitely what Terraform is going to be using to connect to and deploy your infrastructure, you need to create an admin account. So under people, you can create an additional sub account that is not part of your main account. And then you can grant this sub account the API permissions that Terraform requires in order to interface with the UpCloud API. And then once you've created the appropriate sub account and you've added the required API permissions, you can simply export these UpCloud username and UpCloud password environment variables, and these will be automatically picked up by your Terraform UpCloud plugin when you deploy your infrastructure. So now we can take a look at the main.tf file of our infra UpCloud infrastructure module. So the first thing we're doing here is basically creating a private network that we're going to use as the private network of our Kubernetes servers. So all of the servers in the cluster will have a private network which has this address that they'll use for internal communications from node to node. Yeah, so we can set some additional information like the zone of the network, which is going to be the actual zone of where the servers are going to be deployed, and then give the network a name as well. Then the next thing is the UpCloud server resource that is going to help us deploy a group of control plane nodes. So we can set a count for this resource. How many control plane nodes do we want to be deployed? What kind of host name we want for each of the nodes that we deploy? And of course, the zone has also to match the same zone that we have our private network in. What kind of servers do you want to deploy? How big the servers are? So we can use an UpCloud server plan for that. And of course, all of these values are defined as variables, and we're going to look at the variables file later on so that you can see the actual values of all of the things that we are deploying. Then we also have a storage template or the operating system that we're going to be deploying on these servers. Then we add some network interfaces onto the control plane nodes. We're adding a public interface, so all of our servers will have public IPv4 addresses. And then we also have the network interface that connects to the private subnet that we created at the beginning. Then you also have the option to add some labels onto each of the servers that will be created. And then we can define how to log into each of these servers. So you can pre-generate an SSH key pair. Then you add the public key as an SSH key in the login section. Then similarly, just like with the control plane servers, we can do the same with the worker servers. We can set a count of how many servers that we need to deploy as worker nodes. Then we also have a worker count variable that we're defining in a variables file. Then the same options also apply: the host name, the zone, the plan, the operating system, the public interface, as well as the private interface to which we are connecting all the nodes in the Kubernetes cluster. Then we can add some labels. And then of course, don't forget to add any SSH keys that can help us connect into the servers once they are up and running. Then of course, we're going to need a load balancer that is going to help us to load balance across the control plane nodes so that we can access our Kube API server via the load balancer. This load balancer can also help us with ingress access. Once we deploy an ingress controller onto the cluster, we can also use this load balancer to load balance across all the nodes in the cluster on the ingress controller node port. So for the load balancer, we can set a name for the load balancer. Then we can also set a plan for the load balancer. Basically, what is the size of the load balancer? How powerful is it going to be? And then the zone of the load balancer, it has to be in the same zone where we deployed our servers. And then it also has to connect to the same network interface to which our servers are, so that we can easily add these servers as targets into the load balancer. We also need for the load balancer to also have a public IP address that you can access the load balancer over the internet. So once the load balancer is created, we need to start creating our backends. Backends is basically a group of servers that are going to act as backend servers to which the load balancer is going to be forwarding traffic. So the first backend that we are going to create is the Kube API backend. So now after creating our load balancer, we also need to be able to compute some values that we're going to be using in the following resources, like when you create backends and load balancer front ends. And we're going to do that here in this local section. For example, we're going to need control plane IP addresses. We're also going to need the IP addresses of the worker nodes. So we're adding all of these IP addresses basically into a bigger list: control plane plus worker private IPs. So we're going to use this list of all IP addresses, both control plane and worker IP addresses, in the next section. And then we also need the DNS name of the load balancer. So we're just getting the network DNS name of the interface of the load balancer that has a type of public. So now up here, we created a backend, which is a backend for the Kube API. So what we need to do now is add some members onto this backend. So we can do that with the UpCloud load balancer static backend member UpCloud resource. So the count, or the number of actual members that we're going to add into this backend, is going to be the actual length of the control plane IPs. So we just need the IP addresses of the control planes, and that is what we're going to add as members into this backend. So here we select which backend we're actually adding these members to, and then the actual IP address of each member, and then the port. This is the port 6443, which is the actual port that the Kube API server on each control plane node is listening on. Then once we create a backend, we also need to create a front end. This is basically like a front end on the interface that is public facing on the load balancer, that is going to be accepting requests from the internet so that it can then forward them them into the backend that we just created. So of course, the important information is that we define what load balancer we're creating this front end on and what is the default backend, which is the backend that we just created a while ago. Then the port is also important, and as well as the mode. This could be TCP or HTTP, but since we are connecting to the Kube API via HTTP, you can leave the mode as HTTP. And then the network interface that we add this front end to is going to be the network interface that is public facing, or the second interface on the UpCloud load balancer. Then just like the Kube API server, we can do the same for our ingress controller. So here I'm creating a backend that is going to be used for our traffic ingress controller. I'm adding members as well, which is going to be the list of all servers in the entire cluster. So this is all control plane IP addresses as well as worker private IP addresses. Then we can set a port for the backend. So this is port 31100, and we can later on set this as the actual node port that the traffic ingress controller is going to use. Then we can set a front end for traffic. Then at the end, we also have some outputs that are going to be used by the next module in line. So we have our control plane IP addresses, our worker node IP addresses, private IP addresses as well as the load balancer DNS name. So once the infrastructure has been provisioned, we can now move on to the K3S install module. Now this is going to help us deploy our K3S distribution onto the servers that have just been provisioned. So in the K3S install folder under Terraform, you can see the TF files for this particular module, and then under version, we can see what plugin that is going to help us to do all of this. So we're just using the SSH plugin. This basically helps Terraform execute commands on remote servers via SSH. So let's take a look at what is in our main.tf file and what we're doing here. So the first thing we're doing is computing some values in a local section. So once again, we're getting the IP addresses of all of the servers that have been provisioned by the infra module, and then we want to install prerequisites. So all of the servers are going to need to have some prerequisites installed on them before we can go ahead and deploy our K3S Kubernetes distribution. So once again, we can create an SSH resource called install prereqs, and this is what we're going to use to install the prerequisites. And then how many times it's going to run is going to be, of course, the total of all of the nodes that we have so far provisioned for our Kubernetes cluster. Then we can set a host IP address and also the credentials that this SSH resource plugin is going to use to connect to the host. So what are the commands that we are running? It's just a simple update and as well as curl, which is required for our K3S install process. So the next SSH resource that we're going to create is the install K3S server resource. Now installing K3S Kubernetes requires that we first install it on a single server. So this is going to be the first control plane node in the list of nodes that we have deployed. And then we supply the K3S install command that will go ahead and deploy K3S Kubernetes on this first control plane node. So again, you can look at the documentation for K3S to see all of the install configurations and all the ways in which you can deploy K3S Kubernetes onto your server. So you can easily modify this command according to what kind of custom requirements that you need for your Kubernetes cluster. So here I'm just setting a -- cluster init option, which is going to enable all control plane components on this node as well as etcd. And then the -- TLS option basically adds the load balancer DNS name as a subject alternative name to the Kubernetes API TLS certificate. So we want to make sure that this runs once we have all dependencies installed on all of the servers. So we add a depends on field here as well. So once the first control plane node or the server node in the K3S cluster has been deployed, we can now retrieve a server node token that will help us to join other nodes onto this cluster. So we can create another SSH resource, get server node token, and the token is going to be located at this path on the first control plane node or the server node that we have just installed K3S on. And of course, before we can retrieve this token, we want to make sure that the install K3S server resource has already been deployed successfully. So now before we go ahead and deploy our remaining control plane nodes, we need to first compute some values here. We need to make sure to get a list of all the other server IP addresses because we want to exclude the first node, which we have already deployed K3S on. So we can do that with a slice operation inside of Terraform. So now once we have the actual server node token, we have the list of the remaining control plane nodes, we can go ahead and deploy the rest of our control plane. For that, we have another SSH resource, install K3S control plane, and the count, the number of times we want to run this operation is the number of servers that are left in our control plane nodes that have not been deployed to yet. And then we can specify the command that is going to join these nodes as control plane nodes onto the K3S cluster. So in the command with -- token, I can also specify the actual server node token, and then I'm specifying cluster init as well, so that these other nodes also come up with control plane components as well as with etcd. And of course, we want this operation to run once the server has also been deployed successfully. And then once you're done installing the rest of the control plane nodes, you can move on to installing the worker nodes. So the worker nodes will also be as SSH resource, and then the count or the number of times that we're going to run this SSH resource is going to be the number of worker nodes that we have provisioned for our Kubernetes cluster. And the host is the IP addresses that are in our worker IPs list. And then the other thing that is different is the command to join a worker node onto the Kubernetes cluster. So here we supply the K3S URL, which is the URL of the first control plane node, as well as the server token that will be used to join the worker nodes onto the Kubernetes cluster. Then once the cluster is up and running, we can go ahead and get the kubeconfig, which is going to be stored at this location on any of the control plane nodes. Then we can create some outputs, which is basically the output of all the operations that we are running. And then also we need to output the kubeconfig file that we can use to access the cluster. So this K3S install module is going to install a full Kubernetes cluster. So once this is done, we can go ahead and of course deploy some applications that we want to have pre-installed onto the cluster when it first comes up. So we shall do that in the apps module. And then the apps module as well, if we go into the version.tf file, is also using the same SSH Terraform plugin. So if I go into the main.tf file, here I have two SSH resources that are going to install traffic ingress controller as well as the cert manager onto the cluster. So what I'm doing here is I'm copying a file, which is a manifest file that contains the traffic Helm chart that is located in this Terraform directory under the manifest directory. And I'm going to store it in this location on the control plane node, which is varlib rancher K3S server manifests. Now this is K3S specific. K3S has this feature where if you drop any kind of Kubernetes manifest within this directory, the cluster will go ahead and provision or deploy all the objects in that manifest file. So you can take a look at this traffic.yaml file. It is under manifests, traffic.yaml. So these are basically the objects that are going to be deployed. I'm going to create a traffic namespace, and then I'm going to deploy this Helm chart custom CRD. This is a custom CRD used in K3S that helps us deploy Helm charts. So under metadata, we have the name. It's going to be traffic, and we're going to deploy this Helm chart in the traffic namespace. So under repo, you can specify the URL of the repository and then the actual chart from that repository that we're going to use to deploy our traffic ingress controller. So our target namespace is going to be traffic, and then here I have some values that we can use to override some of the default settings in this chart. So all I want to do here is set the service type of the ingress controller to node port, and then set the actual node port to 31100. So if you recall, in our infra module, when we were setting up the back end for our traffic ingress controller, we specified a particular port that we expect our ingress controller to be listening on. So this manifest here will go ahead and deploy our traffic ingress controller onto the cluster. We also have a cert manager manifest, which will create the cert manager namespace, which will also deploy the cert manager release from the cert manager Helm chart. So we can add as many manifests as we want into this section and have them copied onto the K3S server node so that we can deploy as many of the applications or pre-provision as many of the applications that we want onto the cluster. So in the main.tf file, I have the traffic SSH resource, which is going to copy the traffic manifest into the manifests directory on the server node, as well as another SSH resource that is going to do the same for the cert manager deployment. So it's also important important, this project is also highly customizable, that we can set different values in order to create different kind of configurations for our cluster. So here in a variables auto.tfvars file, I've set some of the variables that are customizable. For example, you can set the cluster name, you can set an environment. This environment variable can be used as one of the labels that we add onto the nodes that we're deploying. We can also specify how many servers we want in our cluster, where we want the kubeconfig file to be stored. Then we can also specify what credentials that we are going to be adding to the servers and how we're going to be connecting to the servers, what kind of SSH username and things like that. Then we can also define things on the cloud vendor level. For example, the zone or the location of where we want our cluster to be, the size of the servers, what kind of operating system, and a lot more things that we can basically extract from the modules and then have them defined here in the variables file so that we can highly customize each Kubernetes deployment. So all that's left to do now that we have built out our entire Terraform project is just to go ahead and deploy all of the infrastructure as well as the Kubernetes cluster and the applications into our UpCloud platform. So I can move over to the Terraform directory. I can do a Terraform plan just to see what kind of infrastructure is going to be deployed by our project. Here we have some output about all of the infrastructure that's going to be deployed, the Kubernetes cluster deployment, as well as the applications that are going to be deployed in the cluster once the cluster is up and running. And if you have no errors, then you can go ahead and do a Terraform apply to go ahead and deploy the infrastructure as well as the Kubernetes cluster into the cloud. So while that is running, we can go ahead and check our UpCloud web console and see if everything is being deployed. So in the UpCloud console under servers, I can see that all the servers are being deployed. I have the control plane nodes, 3 control plane nodes, as well as 2 worker nodes as I defined in the Terraform configuration. And all of these are managed by Terraform. So they have been created and they are still provisioning. Yeah, once they are all fully provisioned, this is going to turn green. Then if I go over into the networks and into the private networks, you can see that we do have the network that we defined also being created here. And then under load balancers, our load balancer is also being created and it's currently being set up. And once it is ready, this should also turn green. Okay, so after this runs for some time, we can see that this has successfully completed. So this took about just under 4 minutes to complete. So we have all of our infrastructure deployed. We have the Kubernetes distribution deployed as well. And we also have traffic and sat manager deployed onto the cluster. So we have some output here. So we can go ahead and check some of the output just to make sure that everything was run without any errors. Yeah, so we see how the prerequisites were installed. We did an update, we installed curl on all of the servers, and then we have the K3S install output. So this is a worker node that installed the K3S agent onto the worker node and successfully started the K3S agent daemon. And this is the second worker node as well. And then on the control plane node as well, we're able to start K3S as well, all 3 of the control plane nodes. Yeah, so it looks like everything deployed successfully. We don't have any errors. So you can see our load balancer is now running. It has turned green. So if I just go into the load balancer, check on the backends, I can see we have our Kube API backend is also running. 3 members out of 3 are up, as well as the traffic backend, 5 members out of 5 are up. All our front ends have been created successfully. And if I go into the servers are also up and running. They're all been started successfully. I can just click on to one of the servers here and just take a look at the configuration. So this is the first control plane node. And we also have the labels that we configured. The name of the project is Case Auto. It's a control plane node, and this is a development environment. So all of our infrastructure has been successfully deployed. Now we can check and see if our Kubernetes cluster is actually running. So if I run a kubectl get pods and use the kubeconfig that has been created in the root Terraform directory, I can see that I'm able to access the cluster. I can see the kube system components are all running successfully. And you can also see that our default apps have also been added to the cluster. We have our sat manager deployment as well as our traffic deployment here. And then when you take a look at all the nodes, you can see that we have a total of 5 nodes in the Kubernetes cluster, 3 control plane nodes, 2 worker nodes, and they're all ready. And our Kubernetes cluster is up and running. So now we have successfully deployed our cluster. We've created our project. We've been able to use Terraform to deploy a Kubernetes cluster based on K3S in our cloud provider using UpCloud. So we're able to deploy a Kubernetes cluster of any size within minutes, and also provision some default applications onto the cluster. So I'm going to have a link for the GitHub project in the description below. So you can take a look at the project and try and play around with the project, see if you can provision some infrastructure. Of course, you can also use the discount code for UpCloud. So to go ahead and get started with automating Kubernetes in UpCloud. Yeah, and let me know your thoughts. Perhaps there's some kind of functionality you want to see added, some other Kubernetes distribution or some other infrastructure as code tool. Let me know your thoughts in the comments below. And once again, thanks a lot for watching. If you find any kind of value in this video, please leave a like. Don't forget to subscribe, and I'll see you in the next one.